Hello class, this is Mr. Parsons here. I just want to take a few minutes to talk to you about scatter plots and association. So when we're talking about bivariant data, we're looking at data with two different variables because bi means two. Scatter plot is a graphical representation of bivariate data. And so with that, you'll be able to look at the relationship between two variables, notice if there's any patterns or trends within our data, and then you can also use to help describe any correlations that's positive or negative. With correlation, a positive correlation, if you got scatter plots, that's generally as your x increases, your y increases. So it looks like it's going upwards. All right, your scatter plots, the general direction. Your negative correlation, conversely, your plot of data, your cluster of data looks like it decreases as your x increase. If there's no correlation, they're not clustering. They're just like different plots all over the place, and it doesn't form any type of association. Clusters, what I just said, it's just basically points that are like together, that are kind of grouped together in a general area along the graph. Any points that are not like grouped together with other points on the graph, those are called outliers. This is an example here. We're looking at correlation, and we're looking at the scatter plot and want to determine if it shows a positive, negative, or no correlation. All right, so look at this cluster of data right here. All right, it looks like it's forming some type of relationship here. But if we look as the height increases, meaning as your x increases, look at what's happening to your weight. It looks like the weight increases for the most part. So it's forming some type of correlation. It's a positive correlation here. And so we're looking at scatter plots. We're using our as a graphical display of your data for observing trends, patterns, or associations between two different variables, just like we stated. If it resembles a line, because it forms like a line, all right, then we could say it's linear. If it doesn't form like a line or a relationship, then it's not linear. So if you look, these are the types of ways you can see your scatter plots as far as association. And we just looked at an example as well previously. Positive association, all right, that generally as your x increases, your y increases. Look at what's happening with your pattern of data. All right, it looks like it's going upward. All right. And then negative, as your x increases, the y decreases. Look at your pattern of that, your cluster of points is generally going in a downward direction. No association, that one variable does not have an effect on the other. So those points are like all over the place along your graph. And so let's look at this example here. The scatter plot shows the number of landline telephones in the United States and 100 million since 2000. The graph of the scatter plot shows positive, negative, or no correlation. So look, it's kind of like a line. It's definitely a correlation because look how it's formed. It's formed like a line. The closer to a line it gets, the more of a strong association it has. We just got to see what type of correlation that it has. Either positive, negative, or no correlation. So look, as the number of years increase, look at the number of landlines. The number of landlines decrease. So it's going to represent a negative association. All right. As time increases, the number of landlines generally decrease. All right. Causation is basically saying, hey, one variable has a direct effect on the other variable. All right. And so think about it as cause and effect. Correlation can be determined easily. Causation is a little bit harder to determine, because causation is a lot of different factors. So it's easy to determine if they're correlated. It's harder to determine the variables have causation. And so what you want to do as far as that, of course, look at your scatter plot, determine if there's a correlation, and then look at the two data to see if they have any effect on one another. So for example, does a person's favorite color affect their height? So see, that's not a causation there. Like, just because my favorite color is blue, it doesn't cause me to grow or shrink, you know, vice versa. So you got to kind of think about how the two variables are related when you think about causation. Look at this example here. We're looking at the consumption of mozzarella cheese and the number of engineering doctoral degrees. Already look at those two variables. How much mozzarella cheese versus the doctoral degree? Does me eating mozzarella cheese affect me getting a doctoral degree? So that's some of the kind of things that you want to think about as you look at your graph. So you want to determine if it's correlation or causation or both. We do have a relationship here. There's an association. As the number of mozzarella is consumed, right, the number of doctoral degrees increases. So there is correlation. But as far as causation goes, there's no association between those 2 points. So the consumption does not contribute to anyone getting a doctoral degree. They're not related. All right, so causation, we're trying to see if one variable that has an effect on the other variable. All right, and so you just want to look at what are your two variables that you're comparing. Does it have an effect on one another? So let's take a look. The positive example shows causation because the number of hours studied on the exam causes the score to change. So that's an example, right? The more hours that I study, the more prepared I am, and the chances of me making a higher score on my exam increases. All right, so let's look at this example. The number of cars in a restaurant parking lot increases. The number of available seats inside the restaurant decreases. Is there association? The more people come up to a restaurant, right, the less seats there are. So you're going to have a negative association. All right, now is it causation? Think about it. Hey, you hungry? You going out to a restaurant? You see that the parking lot is packed, so you already know you're finna have a wait before you go sit down and eat. So it is going to be causation because the more people are there, the less seats are available for you to go in and dine at your restaurant. So that does have a direct effect on the other variable. Let's look here. As your height each year increases, the average annual price of gas increases. Is there association? Yeah, because as X increase, Y increase, that's a positive association. Is there a causation though? Like, does my height determine the price of gas? No, so that's not causation. So you kind of want to look at the two variables, see how they're related, if they're related at all, and you can determine whether or not it's causation. All right, and so let's take a look here. Determine if it's correlation or causation, and we're looking at the number of sunscreens sold versus the sunglasses sold. Look at it. My sunscreen sold increases. My number of sunglasses sold increases. So there is a positive correlation here. All right. But as the number of the sold increases, so it shows correlation. But does the sunscreen affect the sunglasses? It's hard to determine. So you can't really say causation here, but we definitely can say correlation. Let's look at these scatter plots here on the right. So both of these show positive association or positive correlation here. All right. And so which one has the stronger association? So when you want to look at correlation, the strength of your correlation, look how close together the points are. The closer they are together, the stronger the correlation. The more spread apart they are, the weaker the association. So if I look at point B is closer than point A. So point B will have a stronger correlation than graph A. And so when we look at the strength of our correlation or association, that's our correlation. And so we want to look at how weak or how strong it is. How do we do that? We do what we call correlation coefficient. Correlation coefficient is defined as lowercase r, and it's a range between -1 and 1. The closer you are to 1, that's the strongest positive association you can have. -1 is the strongest negative association you can have. So the closer you are to 1, the stronger the positive association. The closer you are to -1, the stronger you are to negative association. All right. And so that's kind of like the range from strong to weak with our positive and negative correlation. And so we look here. If we look at these 4 graphs, we want to determine, first of all, if it's positive or negative and how strong and how weak it is. Look at A. Look at graph A. Graph A looks like it's a negative association. All right. But graph C is also a negative association. So you want to kind of compare. So graph C looks stronger than graph A. So then let's look at our negative correlations here. We got negative 0.9 and negative 0.5, right? So since A looks the weaker, right? Now we can say graph A will be negative 0.5 because it's not strong. Look at graph B. Graph B is a positive association, but graph D is also a positive association. But graph B is a stronger correlation than graph D because the points are closer together. Look at your positive correlations here. So between the two, since graph B is stronger, we can infer that graph B would be 0.8. Well, if point A was negative 0.5 and point C is a negative association, now we can say point C would be negative 0.9. And if graph B was 0.8 and it's a strong positive association, graph D is a weak positive association, we can say that graph D is 0.2. All right. Now, to find our own correlation coefficient, all right, and this is what we'll do in class. We could do this in our Desmos, or we could do it on our graphic calculators. But basically what we do is, to find our correlation coefficient, the number times practice versus the number of mistakes. So what we do is in your Desmos, all right, remember how we open up a table, you do the plus sign, go to table, and then we type in our order pairs. We do the same thing for here. This is our X, this is our Y. So we'll open up a table, right, and we'll type these in, and then we create our regression. When we create our regression, then you want to look for the letter R, rounded to the nearest 100. When we do that, we see that we get negative 0.93. Now, if we look at negative 0.93, it's very close to negative 1, which tells us that we have a strong negative correlation. All right. Let's take a look at this one here. All right. We're looking at the number of students that were members of the robotics club and the photography club. Again, we want to find our correlation coefficient. In Desmos, we go to our we do our plus, and we do our table. We type this into our table. The robotics will be our X. The photography will be our Y. We type in our order pairs. We create our regression, and we look for the letter R. We see what the R equals to, and we round it to the nearest 100. When we do that, we see that we get 0.85. All right, 0.85 looks like that is a strong positive correlation, all right, between the two. Do either of these tables above represent causation? Now, in the first table, you looked at the more times you practice, the less mistakes you made, versus the people of the robotics club versus the people of the photography club. Look at those two associations. Like the people of the robotics club doesn't necessarily have an influence in the people that attends the photography club. Whereas the number of times you practice has an effect on the number of mistakes that you make. So it looks like that the first table would be causation, or more likely to be causation. All right. And so what we looked at here is we looked at scatter plots and correlation, or association, right? And so what you want to look at is look at your scatter plots and see what kind of pattern does it goes. As X increase, your Y increase, that's going to be a positive correlation. As X increase, your Y decrease, that's a negative correlation. And if you just got random plots all over the graph, is no correlation. All right. And then what you want to look at is, does it have causation? Meaning, does this one variable directly cause the other variable to happen? In addition to that, we look at how strong and how weak our correlation is by looking at our correlation coefficient. The closer it is to 1, the stronger the positive correlation. The closer it is to -1, the stronger the negative correlation. And you could tell graphically by how closer the points are together. The closer the points are together, the stronger the correlation. The more spread apart the points are together, the weaker the correlation. And so I hope that helps with our understanding of scatter plots and association.